Alrighty, there we go. So we are back. So just to recap, guys, we were mentioning here in the projects, we have the Eagle folder. Thank you for joining First Flights. As we mentioned before, this is the schematic design episode. In the control panel, which will be discussed in a future episode, we're just going to go over here what's pertinent for starting your project. We have the Eagle folder and examples. Eagle folder in each OS is created in the Documents section, so you wish to make sure, or we recommend, that you store all of your work there. The advantage of doing this is that every installer of Eagle expects that folder to exist, and so will automatically pick it up. You won't have to move files around. The other advantage is that because it's in the Documents section, it's not exposed to tampering by the OS or having any type of file restriction on it. Since under Mac, Windows, and Linux, the Documents folder is a free area. So you're not going to be affected by user access control on Windows or by any restrictions to the Applications folder under Mac. So we're going to go over here. I right-clicked to create a new project. If we go down, we'll find it at New Project over here. Let's go ahead and rename it. I'll call it Schematic _ First Flights FF. I'll say that. I right click on it, New Schematic. So as I mentioned, take a good look at this screen layout. We're going to be basically using it often. It pops up in all the other editors. So there's a lot of consistency in the GUI in that regard. There may be a few icons missing depending on the editor you're working with, but in general, you'll see everything here. Everything that's here. So again, I'm going to minimize this here to get a bit more screen real estate. I think we have a comment. Okay, no, we're good. So,
I take care of that.
Oh. So let's go ahead and start. The first thing we generally recommend is to define the work area. Eagle comes with a library called frames. So I clicked on the add dialog. You notice that the first time it's going to take a little bit because it populates all of the libraries on the first click. After that, any successive run of the add command will be much faster. Additionally, if you update a library, then the next time you hit the add command, it will go through the same population process. So these are all the libraries that ship with Eagle. There's probably a few of my personal ones in here as well. By default, Eagle ships with about 300 libraries. Now in my case, I know where everything is for this demo, but I do want to highlight a couple of things to keep in mind when using the add command. So first off is that Eagle search is an exact match search. So if you're off by a letter or a number relative to what's in Eagle's libraries, you're not going to get a result. So you can be close, but close is not good enough. So as an example, let's say I just search for LM555. If I search for that, you guys will see that I get a sorry, no match. Now the 555 timer is a very old chip, very common. Anyone who's been in electronics for any amount of time is familiar with the 555 timer. So what's the deal? Well, what you want to do when searching for parts in Eagle is you want to make liberal use of the wildcard characters. And Eagle uses Unix wildcards. So first off, you have the question mark, which basically is a wildcard for a single character. So what this search is saying is, if the device name, or within any of these items here that you see, description, preview, SMDs, and paths, within any of these items, I find LM555 with some character on the end of it, doesn't matter what it is, please take that back because that may be what I'm looking for. So if I hit enter on that, you guys will notice that now we do have some results. And we get the LM555D, which is the surface mount, and the LM555N, which is the through hole. And at this point, because we know it's an exact match search, we know why it didn't pop up before, because I hadn't included a D or an N. Now we can generalize it even more. If I remove the LM and I put an asterisk, now asterisk is a wildcard for an arbitrary number of characters. So what this search string basically represents is it doesn't matter what the part name starts with, as long as it has 555 and ends with some character, doesn't matter what it is, that's a valid search result. Let me have a look. So if I hit enter on this, Now we get a few more results. Some of them are going to be gibberish because we don't want a decoder. But if we go over here, now we find the NE555, the SE, the UA. Okay, so that's our example here. I'm going to go ahead and click it to use it. I'm going to place one of these. Now if you notice, I can continue to place as many as I want. I can hit escape to go back to the dialog, clear it, and now search for another part. So as you can see, maybe you don't want to put in all of your parts at once, but definitely if you've designed sections of your circuit, you can bring them in one at a time by the section. So you can bring all of your power supply in at once, you can bring in all of your microprocessor circuitry in at once, and that's going to save you time in the long run. So right now, because I know the design that I'm going to go with, you're going to see that pretty much I bring everything in one go. So to define the work area, we're going to use frames. Eagle comes with the standard paper sizes. Now these are just default frames. You can create your own. You can modify these to suit your purposes. I'm going to go ahead and use a landscape. I'll say OK. I'll go ahead and place this one. Again, you can see we can continue to place them. I'll hit escape. I'll go back. Let me go ahead and bring in my passive parts. These are in the RCL library. That's a library you guys are going to want to be familiar with, because this is a library that we work with often. It contains all of the passives, especially in the case of capacitors and resistors. You'll pretty much find everything you need here. Inductors, because of the laws of physics and magnetics, their shapes are often not as standardized. But in the case of resistors and capacitors, most of the standard stuff you'll find here. So I'll go ahead and bring in a capacitor. If you notice, we don't sort them by power as some places do, simply because power is not an accurate definition of package. You may see that a 1 watt resistor may be a different size than another manufacturer's 1 watt resistor. So here we define them based on the actual physical dimensions of the component. So for the through holes, in the case of capacitors, what you're going to see is this first number, the 0.25, is the separation between the pads in millimeters. So this first capacitor here, these two pads are 2.5 millimeters apart. Then we have the width of the capacitor, which is 2.4 millimeters, by its length, which is 4.4 millimeters. Okay, so that's how the convention works with the capacitors. Pretty straightforward. In the case of the surface mount, because there are standard IPC codes for those, you'll find 0805 or 0603. When working by hand, I like to use 0805, so I'll use that in this case here. So I'm going to go ahead and bring in 3 of these. 1, 2, 3. Going to go ahead and bring in my resistors. For resistors, you'll see something similar. In the case of resistors, what you'll see is that you'll have, again, the width by the length, so 2 millimeters in width by 4 millimeters in length, and then the number after the slash, after the forward slash, is the separation between the pads. Again, for the surface mount parts, you'll see that we use the standard convention 0805, 0603, so on and so forth. I'll use again 0805s for this. And I'm going to need also 3 resistors. 1, 2, 3. And finally an LED. I'm sure those of you who have worked with 555 timers before kind of getting an idea of what this circuit is. So we go to LED. There's a whole bunch of them. I like to go with the generic for this example. So I'll just go down to LED. I'll select 5 millimeters and I'll bring that in. Okay, so that's good enough to start. Let me go ahead and clean up some of this. Just maximize my view. Okay. Now in Eagle, you'll notice we have the whole verb-noun paradigm, and that's one of the things that initially throws users for a loop. With the release of version 8, there's actually a few different ways to handle this. So probably the most intuitive way for you guys is just to group everything and then just hit the delete key. That'll get rid of it. To the Control Z to bring it back. Another option, and which would be the old, more canonical way, is to just activate the delete command, and then you can just delete each one individually. So use whichever way is more comfortable for you. I know that for most of you, the new group mode would probably be the most intuitive for deleting things. So I'm going to go ahead and move some of this stuff around, and I'm going to use the modal way, which I find that more comfortable if I'm going to do a bunch of single moves. So I've activated the move command. It's going to stay active as long as I'm moving things around. And I find that for single operations, the modal mode is a lot easier and a lot quicker, even if it takes a little bit of getting used to. Okay, let me just put this over here. This guy right about here. Let's put you over here. That should be fine. Now if you guys hear a beep, if I'm not close enough to the handle of the object, then Eagle doesn't see a selection and it'll beep. Alright, that seems pretty good to me. Now let's go ahead and start making some of our connections. Now one point that used to be really critical, although it's not as critical now, when working with the schematic, is that you should always stick to a 0.1 inch grid. We still make that recommendation, although now, thanks to a pin snapping feature that has been added to the net command, it's no longer as critical that you strictly stick to it, but it is still a good idea, because all of the libraries within Eagle, all of the components you'll find online, are all built to that 0.1 inch grid, so it'll make it a lot easier to connect things. But again, with the pin snap, you'll see that it works pretty seamlessly. So we're going to use the net command to define our connections. Don't use line. It used to be a little bit more confusing because line used to be called wire, but now it should be pretty clear that you want to use net. So click on net. Again, the net command will stay active. You'll notice that Eagle automatically snaps to the pin. So I just go pin to pin. Okay, very simple to make the connections. I can rotate the bend style by just right clicking. There we go. You'll see it automatically terminates the connection. Nothing to worry about there. Okay, bring this over here. Okay. Now one thing that you guys, if you have any experience designing electronics, you don't want to do is you don't want to kind of overlap like this. Even though a connection won't be formed, visually it's a little bit disconcerting. So always make sure that for things like this you kind of break away a little bit. Give yourself room, especially on a circuit like this where you have room to spare. There's no reason to not do this. Okay. And when I connect it, you'll see it will automatically places a junction dot for you. Okay. So let's see over here. I'll do something like that. Now one thing I'm going to do to kind of clean this up just a little bit is I'm going to go ahead and do a Control M for move. Just to kind of clear that up a little bit. That's just one higher. Okay, switch back to net. I'll start here. Now you'll notice that here Eagle is seeing that there's a naming conflict, and it's basically asking, do you want to rename to this new name? In general, you're going to say yes. So if in doubt, say yes. You won't harm anything by doing so. And you can always confirm the name by using the name command. In Eagle, all connections are defined by net name. So if two pieces of wire have the same net name, they are connected. And we'll see that shortly with the supply symbol. So this part's okay. Let's go back to net. So far, all the main connections are in, you guys will probably notice that we do not have the power supply rails in yet. Let's go ahead and bring those in. So we'll go back to add. And the best way to bring them in is to use supply symbols. Now Eagle comes with supply libraries already that cover the most common rails. So you see 3v3 plus 5 plus 12. You'll find other options in supply 2. Now the kind of odd thing with supply symbols is that you can't rename them. If you rename them, it won't change the signal that they represent. That's why you'll notice that we've had to create all of the rails kind of as individual supply symbols. So make sure that when you use one, you don't try to rename it, because that won't do anything. So I'm going to use a 5-volt rail. Say OK, put that one in here. Let's put that one. Hit escape. I'll pick ground. There we go. Let's put that. I'm going to put this one here. Now just to kind of illustrate the use of this command, you can use copy to make a copy of any of the existing parts. You can do it with the group as well. Okay, let's go ahead and make our connections. There we go. Guys, if there's any questions, please feel free to bring them in at any point in time. So again, it'll say merge and $2 onto ground. We want to say yes. Now the benefit of supply symbols, for those of you who are familiar with other schematic capture tools, is that it avoids having to draw an explicit net between all the grounds. All of these grounds, by virtue of being supply symbols, are automatically connected. Same thing happens with the 2 plus 5 volts that are here. So it can really help keep things very clean in your design. So that part's been done. Let's go ahead and add values. We want to make sure that we put values on all our components. We can do that with the value command. And there's actually 2 ways to use it. One way is you can just manually type in the command line. Because the command line always has focus, you don't have to do anything special. So I can say 0.1 micro, hit enter. And then when I hit on a cap, it automatically gets that value. Another way to do it is if I just don't enter a value and I click, then it asks me for a specific value, and I'll put in 1 micro. I can do that. Let me fix this one, because this one should have been 0.1. My mistake on that. Same thing with the resistors here. We'll have 150K, and I'll put 100K on this one. I'll put 180 ohms on this one. You can just leave it without the suffix. Some guys like to put in the word ohm. I like to leave it without the suffix. It's all up to you guys and what your convention is. Okay, so that basically covers the schematic. The only thing we're still missing is a connector to get power onto the board. Even though we've defined our rails, we don't have any connectors to bring power onto the board. So let's go ahead and go back to the add command. And Eagle has a whole bunch of connector libraries. They're all prefixed with the word con, and they're organized by manufacturer. Okay, so usually you can find what you're looking for here. But for this example, there's another library that I wish to use called Pinhead. It's for pin headers, 0.1 inch separation. So let's just go ahead and use a normal 2-pin pin header. Say OK. You can rotate it, put it in. And now I'll just use a copy command and bring over a ground symbol and a +5 symbol. Okay, and there we are. That's our basic schematic. Let me go ahead and just kind of move this down to get a little separation. Right now I think we have 3 to 4 minutes left. Okay, so we have like 5. So if you guys have any questions, please feel free to submit them now. If not, then I'll just take advantage and kind of show a couple of other little neat features in the schematic. Okay, so let's go ahead and I'll show you guys just a couple of features here. So first thing I want to show you guys, it's very basic but sometimes can confuse. You guys will notice that this is untitled and it doesn't have a date. Go ahead and just save this as, I'll just give it a name, Schematic first flights. Okay, when I do that, you'll notice that it doesn't immediately update. To get it to update, you just have to do something that refreshes the screen. So either a quick zoom in and zoom out, you'll notice will now update it. You can add in your own information like I mentioned, and you can also add in, create your own title block and arrange it however your standards are in your company. So let me take advantage now that we have a few minutes and just show you some of the useful UOPs that can be applied to the schematic. UOPs are basically C-like programs that we use to automate a lot of things in Eagle and to produce a lot of output, such as bill of materials output, DXF exports, imports, and so on and so forth. So for the schematic, probably the most critical one is the bill of materials UOP. Now you'll notice it's very basic here. It will actually read in any attributes that you define for components. You can export it as a CSV list to bring it into Excel and add in additional information. Here, right now, it's organized by reference designator, but you can also organize it by values. So it'll give you quantities of each one. It'll tell you which parts in your design use it. So it's a very easy to use UOP and one of the first ones that users will generally play with. So definitely encourage you guys to check that out. Okay, let me go ahead and move these over with the group command. I'll just group everything, and if I left click and hold, I can kind of rearrange, freehand it and put it somewhere else. Also a pretty intuitive action for a lot of you guys. Okay, let me see what else I want to show you. Oh, if you guys notice, these texts by default aren't movable. They'll be however the part is designed in the library. If you need to rearrange the text because of space constraints or just to make things look nice, then the best thing to do is just do group on everything. Select the smash command, which is this one over here. And then if you just left click, it's going to apply it to whatever item you left clicked. If you want to apply it to the whole group, you're going to hold Control. If you're in a Mac, it's the Command key, and right click. And what you'll see is that now all of the text gets little handles. So you can move everything around. We can do something like this, just kind of put it over here. Do something like that. So it gives you the flexibility to rearrange the text however you see fit. Another thing that we could do, for example, is a pin swap functionality. So we can go over here, and even though this would be wrong for this circuit, but just to show it, we could say this pin, you'll notice the pin highlights, and this pin, and you'll notice that Eagle basically crosses them. So right now it'll be kind of hard to see because it did a straight line cross. You can see something like that. Okay. So obviously for a resistor, it doesn't make much sense to do that. But in components like op amps, or when you have multiple gates, like a quad AND gate or a dual op amp or something like that, you can also do gate swaps to basically within your schematic. If later on looking at the layout you find that it would have been easier on the layout to use this gate versus another, you can always do gate swaps in the schematic. So that's a pretty handy feature that you guys can leverage. Anything else that I could go into would be a bit more advanced, like hierarchy and things like that. So I think we could call it here. For the sheets here in the preview, let's go ahead and let's say we add a new one. You can create multiple schematic sheets. You can rearrange them however you see fit. So I can like put it over here, move it around. Oh, one thing for you guys to have in mind. If you have to, for example, rearrange things, you don't do a copy and paste, because that would imply a creation of a new object. What you want to do is you want to go ahead and group everything. Okay? Do a move. Oops, sorry. Group, left click and hold. Click the second page, and then just bring it in. Now I'm rotating, and my right button is a little bit finicky on my mouse, so that's not eagle, it's my right mouse button. I can go ahead and place it, and you'll see it automatically moves. Okay? So what you want to do is move between sheets, not cut and paste, not copy and paste, move between sheets. That's something that oftentimes will confuse new users, so just thought it'd be a good idea to cover that one. So again, I'll just move it back. Let me go ahead and remove these, and we will leave it here. Okay, so thank you guys for joining us today on our First Flights webinar. As always, if there's any questions, you can feel free to post to our forums. At the end of this webinar, you guys will be receiving a link to our forums. As well as if you guys have any other questions, you can feel free to reach us through there. We're almost always on the forums. It's probably the fastest way to reach us. Otherwise, you guys can also try to generate a support ticket through Autodesk. Okay? So thank you guys.
Thank you everybody for joining us today. I went ahead and I put on the chat a link to our forums. Can you mute? Okay, so I went ahead and I added a link to the forum, so that way, in case you want to go ahead and join us there, it will also be pushed on the screen once we finish. Just want to summarize what areas we were covering today. So Jorge gave us a demonstration on how to create a project from the Eagle control panel, which is the first screen you're going to be utilizing to organize all of your projects. You have multiple projects, or if you have multiple clients. Also, we went into creating a brand new schematic, and what are usually the steps that you do when you create a brand new schematic. Usually you want to define the area you're going to be working on. By those means, we used our libraries to find some frames and place them there. And then we went ahead and we gave you a little explanation of how you search in the libraries. That was the most efficient way to search in the libraries, using the question marks as well as using the asterisk. And once you place the components, how you define the connections on those components, how to do pin swapping and gate swapping if you have a multi-gated type of system on your designs. Also, we went through those last steps that usually are very essential when you're working on a schematic, or you're defining or almost done with your schematic, is like create a list of the parts you're going to be needing, also referred to as the bill of materials. Bill of materials will give you that list. You could export them in multiple formats in Eagle. Also, if your components in the schematic editor, if you wish to add attributes to your components, those attributes that you define will also be placed on the bill of material. So if the components that you're using on a schematic, you create an attribute in regards of the manufacturer, who's going to be the supplier, or if you actually have an internal numbering system for the components that you wish to use, you could add those values as an attribute, and they will also be placed as part of your bill of material. If there's anything else that you have questions about, please go ahead and reach out to us. I'll go ahead and put our email address here. So make sure you go ahead and reach out to us. We'll go ahead. Oh man, I typed too fast. Sorry about that. Okay. The session has been recorded. We'll go ahead and be providing the recording to everybody that attended, and we'll also be making it available to the public. Okay. So thanks a lot. Thank you for joining us. Eagle First Flights. We will continue this every second Tuesday of every month. Go ahead and take a look at our schedule. We'll go ahead and try to send you that schedule as soon as possible, okay? Have a great day, and thanks for joining us. Bye.